Hi, welcome to the geometry lesson over quadrilaterals. So lately we've been studying angles and slopes and lines and triangles, lots of triangles, and now we're going to switch to not a triangle which has 3 sides, but a quadrilateral, which is basically a polygon, and remember polygon means many sides, with 4 sides and 4 angles. So in geometry, we have lots of shapes that are classified by their properties with 4 sides and 4 angles. The first most common one, I think, is a square. So a square looks like this, and there are some special characteristics to a square. All 4 sides are congruent. All 4 angles are 90 degrees or right angles, and opposite sides are parallel. Okay? So a square, although it's a common shape to us, one of the first things that we learn, is kind of related to two other quadrilaterals, one of which is a rectangle. So let's look at a rectangle and compare it to a square. So a rectangle also has all 4 angles are 90 degrees, and it also has opposite sides parallel. But a rectangle does not have all 4 sides congruent. So you could say that a square is also a rectangle. It meets all the qualifications of a rectangle plus 1. So it's a rectangle plus 1 additional characteristic. So when we classify squares, they are squares specifically, but they also fall into the rectangle case, and we should label these. Square. And we also have rectangles. Now, a rectangle is not a square. Why is a rectangle not a square? Because one of the characteristics of a square says all 4 sides are congruent. That's the difference between a square and a rectangle. A rectangle has 2 long pairs of sides and 2 short pairs of sides. So while a square is most definitely a rectangle, it doesn't work the opposite way. Then we have another shape that's kind of like a square. It looks like a square that's been pushed over, and it is called a rhombus. And a rhombus kind of looks like this, like a diamond. Most of the time when we see a rhombus, we won't see it sitting on its point, but we'll see it sitting instead on its base. Same exact shape, it's a diamond, what you've been taught was a rhombus. And if you flip that rhombus over onto one of the flat sides, it looks like the picture on the right. Same exact shape. So what's different about a rhombus? Rhombus also has some characteristics that match with a square. All 4 sides are congruent in a rhombus. Every single one of those sides are congruent. Opposite sides are parallel. But what does it not have? It's those all four angles are 90 degrees. These angles, depending on how far you push this over, change. Now, opposite angles are the same, for sure. This angle and this angle are congruent. And then this angle is always congruent to this one across from it. But they're not all four congruent. Depends on how far over you push this square. So a square is also a rhombus. Look. A rhombus says all four sides are congruent. Well, guess what? A square, all four sides are congruent. And opposite sides are parallel. Opposite sides are parallel, opposite sides are parallel. Same thing. So a square is also a rhombus. It's a rhombus plus one additional characteristic. Squares fall both into the category of rectangles and rhombuses. Now let's talk about something in squares and rhombuses called a diagonal. So the diagonal is what divides a parallelogram into two congruent triangles. The diagonal is the thing that goes across the middle. And there are two, 1 and 2. There's the diagonals of that square. And we have the diagonals of this rectangle. And we have the diagonals of this rhombus. So these diagonals have certain characteristics for these three different quadrilaterals. All diagonals of all parallelograms bisect each other. This is a common theme to all diagonals. Even the shapes we're about to talk about, which aren't square, rectangle, and rhombus, all diagonals will bisect. That means cut exactly in half each other. No matter what parallelogram you're looking at, the diagonals will cut exactly in half. Now, why are we talking about parallelograms? So it's important to note here that a parallelogram is a quadrilateral with opposite sides being parallel. Four sides, actually with at least one pair of parallel sides is parallel. Excuse me. Opposite sides parallel and congruent, opposite angles congruent. That is a parallelogram. Opposite sides are parallel and opposite angles are congruent. You are going to see one parallelogram that both pairs of opposite sides are not parallel. So that's why I put in that at least one. So a quadrilateral is a polygon with four sides, and a parallelogram is when you have opposite sides parallel. For instance, square, rectangle, and rhombus. Now, diagonal. All diagonals will cut each other in half. They bisect one another. When we look at the diagonals of a rhombus, specifically a rhombus, they will always form 90-degree angles. So in a rhombus, these diagonals always form a 90-degree angle. Every single rhombus, when you connect opposite corners, you have formed a plus sign that is also perpendicular lines, 90-degree angles, right angles, those diagonals, okay? So another way we could say that would be that the diagonals are perpendicular. The diagonals form 90-degree or right angles. When you look at the diagonals of a rhombus, they also form four congruent triangles. If you look at the four triangles formed down there at the bottom with the purple diagonals, they're all congruent. We've just covered congruent triangles. Now these diagonals also do one more thing in a rhombus. We're only speaking about rhombuses here. So in a rhombus only, opposite angles are bisected. That means get a color on this one. Let's put an orange. This angle equals this angle because that diagonal bisects it. This angle at the top, not the big angle, but just the two that it cuts it into, those are equal. They're actually equal to the yellow ones as well because these opposite angles are equal. So we could actually do that in the same exact color. All four of those angles are the same. And we have four more identical angles here and here because it's a bisector, and there and there. All of those are equal because it bisects opposite angles. Bisect means cuts exactly in half. All of that for a rhombus. Now let's talk about the diagonals of a rectangle. The one thing we know about diagonals of a rectangle is they are exact length. They are congruent. So in a rectangle, the diagonals are congruent, same length, and they form two congruent triangles. You just can only look at one at a time. And if we look at this triangle, we're only going to consider one diagonal at a time. That triangle is going to be identical to this pink triangle. Because a diagonal of a rectangle forms two congruent triangles. Not four congruent triangles like a rhombus, but just two. So if you did that the opposite way, and you looked at the other diagonal, this triangle would be congruent, excuse that ringing, to this triangle. Now, if we look at a square, and we're talking about the diagonal, it's pretty much a combination of a rhombus and a rectangle. So in a square, the diagonals, cut it in both 2 and 4 congruent triangles. So does a rhombus. Those 2 triangles down there are also congruent. So back up 1 second. We could do this triangle is equal to this triangle in a rhombus as well. But even more than that, all 4 of those little triangles are congruent. Same with a square. These 2 big ones are congruent, but also all 4 little ones in a square are congruent. So either piece of information that you need, you have when you have a square. When the diagonals bisect one another, and this is in every single parallelogram, you know that all these, that's equal. And then also these 2, whoops, hard to, these 2 are equal because the diagonals bisect one another. In the square, they're all 4 equal. In a rectangle, all 4 equal as well. They're all 4 equal. Just in these, but not in all parallelograms. So diagonals of a square are congruent to and 4 congruent triangles, and also perpendicular 90-degree angles, and they also bisect the opposite angles, the same as in a rhombus. It's going to be hard to fit all that in there. Pretty close. So keep in mind as you go back to these notes that the lavender text, we're only discussing diagonals of parallelograms. Okay? Whoops, right. Now we've only covered square, rectangle, and rhombus. But there are some more quadrilateral parallelograms, a trapezoid, and a kite. So a kite is that thing that you fly on a windy day. Those 2 lines are equal. And then typically on a kite, those are a little bit longer. If they were the same, you would have a rhombus. So it's kind of a rhombus that has been stretched out a little bit on the bottom part to make a kite out of it. Now on the kite, you also have your sticks. That you put in there and you tie your little pieces of material to. Those on the kite are the diagonals. So the sticks on your kite, or the little pieces of wood, are your diagonals. And we know something about the diagonals of a kite. They are perpendicular, and they also form 2 pairs, so the top little ones and the bottom big ones, of congruent triangles. The diagonals of the kite. So there's a 90-degree angle in there. Let's draw that in there, the information that we have. So this is 90. All four of those are 90. And then if we wanted to look at the triangles, these two are congruent, but also these bigger ones on the bottom, the blue ones, they're congruent as well. Two pairs of congruent triangles, the diagonals of a kite. So a kite also has exactly one pair of congruent opposite angles and two pairs of congruent adjacent sides. So in a kite, what you know is this angle equals this angle, and this angle equals this angle. And what did we learn about the diagonals of all of these parallelograms? The diagonals bisect those angles. So don't forget that when we're looking at, they bisect the angles, so they cut them exactly in half. You're going to have a lot of problems with kites. You have to find these angle measures and remember that this angle is congruent to this angle because that diagonal bisects it. Same here. And the other one. Congruent, 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 because the bisector is the diagonal. Okay? So there's your kite. Last but not least, we have a trapezoid. So a trapezoid has two different forms. The one that we're accustomed to looks like so. And this is the one that I usually say it's the stool that the elephant stands on at the circus. That is a trapezoid. This is specifically an isosceles trapezoid. In an isosceles trapezoid, every single angle is congruent. Every single angle is the same. This angle and this angle are congruent. Excuse me, the top pair, I said every single, but that's not true. The bottom pair is also congruent in an isosceles. What makes this isosceles is this side is the exact same length as this side. And look, angle, side, angle. Kind of reminds me of those triangles that we did. You don't always have to have an isosceles trapezoid. We get it stuck in our head that we do. There's another kind of a trapezoid. Maybe it looks like this. Obviously, in this trapezoid, this angle is not congruent to this angle. Different. This is a right angle, the other ones aren't. And this is its own thing as well. So we'll maybe put 3 tick marks on that. All of those angles are different. It's still a trapezoid, it's just not an isosceles trapezoid. Isosceles trapezoids, the top angles are the same, the bottom angles are the same, and the side lengths on the right are the same. These top and bottom pieces in a trapezoid are always parallel. So remember our little parallel marking when we studied parallel lines. Hence making it a parallelogram. Now the other opposite sides are not parallel. Like when you have a rectangle and a square or a rhombus, only one pair, the top and the bottom of the trapezoid, are parallel. And I really shouldn't say top or bottom because we could actually have a different parallelogram. Maybe this one. Where it's not even necessarily a right angled parallelogram and it's not sitting, excuse me, it's not sitting on one of the parallel sides. So it's not necessarily the top and the bottom, but it's just one pair of opposite sides are parallel. So in this one, the left and the right are parallel. It's not the top and the bottom. So be careful. We can always take this parallelogram and we could flip it up. And it wouldn't be the top and the bottom that were parallel. So there's your trapezoid. You're going to need to use the characteristics of these, improving things later. So study these notes very conclusively. You have a worksheet that is only identifying different shapes based on markings and characteristics. So this worksheet, you're going to be given some congruency markings and you're going to be given some angle markings. For instance, let's look at a couple of our examples on our worksheet. The very first one, it has one pair of opposite sides. We don't have any markings about angles. So this one is clearly a trapezoid because the other things are not there. It's not an isosceles trapezoid because if it was an isosceles, these would be congruent and then angles would be congruent, not isosceles. Here, this is parallel and the other is parallel. So we have what shape there? We don't know anything about angles. We don't know anything at all. The only thing we could say on this one is it is a parallelogram because opposite sides are parallel. That's it. It's also a quadrilateral because there are 4 sides. So both of those technically are correct. Not a kite, not a trapezoid. You're also going to see some on this worksheet that have marking. So if we look at number 14, we're going to look right back at the characteristics that we saw. So opposite angles are the same. Opposite sides are the same length. If you have 2 lines cut with a transversal, same side interior angles are supplementary because 115 plus 165 is 180. Therefore, you know that those lines are parallel. Same with the other pair of parallel lines cut with a transversal. If you look at the ones that are on the left, here's 2 parallel lines. And there are 2 transversals there you can choose from. Still yet, same side interior angles are supplementary. All you can tell about that shape in 14 is that it's a parallelogram. It's also a quadrilateral, but the most specific is parallelogram. We can't tell anything about the others. So on this worksheet, you're identifying quadrilaterals or parallelograms based on the things that you just learned. Now, the ending of this is all possible names. So what could you tell about number 16? You might think it's a parallelogram, but we don't really have any markings. So number 16, the only possibility for sure based on the picture is a quadrilateral. Okay? Now, on number 17, what kind of shape is it? Most specifically, it is an isosceles trapezoid, but it's also got four sides, and it's also a plane trapezoid. It's a trapezoid plus one additional quality, making it an isosceles trapezoid. So all possible names would be D. All right, so in this worksheet, you're really going to have to refer back to the notes that you just took. And that is the point, because the more you refer back to them, the more you're going to know them, because in the next exercise, you're really going to need them. So you're going to upload a picture of your note. From this video, you're going to show all your work, draw your pictures, write your thoughts down. You're going to use homework help for anything that you're struggling on and can't get on your own. And you put your multiple choice answers into the Google form. In our next lesson, we're going to look at these same characteristics, and we're going to find the measures of angle and the length of side using the characteristics once we're really good at picking them out. I'll see you in the next lesson.